Okay, let's take a look at nomenclature of a few simple organic molecules. All right, in this video, we're going to look at organic molecules in general, talk about what we mean by organics. Uh, there are a whole bunch of different classes of organic molecules, uh, alkanes, alkenes, alkynes, aldehydes, and ketones, and ethers and esters, and so on and so forth. When you take organic chemistry, you're going to get to learn about all those different kinds of organic molecules, which actually is kind of a heck of a lot of fun. But for right now, we're just going to focus on two very, very simple types of organic molecules, alkanes and alcohols. And for the nomenclature of these, we're going to look at a system of numerical prefixes. That's a little table, some prefixes that you're going to have to memorize, although a lot of them are numbers that are prefixes that you already know, so that'll be pretty simple. And then we'll look at how to apply those prefixes to the names of alkanes and also to alcohols. Okay, so first, what are organic molecules? Historically, the reason that they're called organic molecules is because these are molecules that come from living organisms. And there was a time back in the 19th century when scientists and chemists thought that the molecules derived from living things were fundamentally different than those from non-living things, and that the two kinds of molecules could not be interconverted. Uh, we don't think that's true anymore, or we know that's not true anymore, but that's where the term organic came from, because these are the kinds of molecules that came from living organisms. So, more generally, or organic molecules are those that contain carbon, right? All of those organic molecules from living organisms are all based on complicated structures based on carbon. And carbon is kind of unique in that it can form these long chains, and it can form ring structures like in this guy down here. It can link together in chains. This is a 3-carbon chain, but you can have a 4-carbon, 5-carbon, 6-carbon chain. You can have very, very long chains. And that allows you to make really complicated and interesting structures. So anyway, organic molecules, generally speaking, are just those that contain carbon as sort of the backbone of the molecule. Okay, now of those um, all different kinds of organic molecules, alkanes are the simplest ones, and alkanes are made of chains of carbon atoms in which the molecule contains only carbon and hydrogen, and which all of the bonds are single bonds. And specifically, all of the carbons have 4 single bonds. So an alkane would look like this, be a chain of carbon atoms. Here, for example, is a 4-carbon chain. And all of the carbons has to have 4 bonds. So if we put a couple of chemical bonds on here, so that all of the carbons have 4 bonds, and then around the perimeter of the molecule, we'll just put in a bunch of hydrogens. Okay. So that's what an alkane looks like. This particular one is a 4-carbon alkane. We could also have a 2-carbon alkane, which would just look like this, right? 2 carbons, and then we put in 4 bonds on each carbon. And then put hydrogens all around it to satisfy all of those bonds. And because of that structure, alkanes always have the formula CnH2n plus 2. Right? And the reason for that is N is the number of carbons. So for example, in this one down here, N equals 4, and in this one down here, N equals 2. All right. So if we look at this one, if N is 4, and we follow this formula here, this means the formula for this would be C4H, and then H is 2N plus 2. 2 times 4 is 8, plus 2, that's H10. And if we do the same thing for the one on the right, N is 2, so the formula would be C2, and then for the hydrogens, 2N plus 2, that's 2 times 2 plus 2, that would be H6. Okay? Now you don't really need to memorize this little formula here, CnH2n plus 2, but you can see why this works out, right? For all of the carbons in the middle of this chain, right, all of these are going to be CH2s, right? So that's why the formula is going to be CnH2n, right? There's going to be twice as many hydrogens as there are carbons, and then there's going to be one extra hydrogen at each end, and so that's where the plus 2 comes in. Right? Same thing is true for this short, this 2-carbon chain here, right? You got 2 carbons there. That's going to be excuse me, I made a mistake on the last one. Let me fix that. It's not C2 that I meant there. I meant CN, right? So for this one over here, the number of carbons is 2, right? So that means C2, and then the number of hydrogens has to be twice as many, so that's 4, and then there's going to be 2 extra, right? So that's C2H6. And the 2 extra, of course, are the ones that sort of serve as caps on the end of that chain. Okay. All right, so alkanes are always going to have this form, a string of carbons connected together, and then each of the carbons has 4 bonds, and then you put enough hydrogens around there to satisfy all of those bonds, and that's going to end up being 2 hydrogens on each carbon plus 1 hydrogen on each end of the chain. And because of that, you'll end up with that formula for all of the alkanes. Okay, so let's look at alcohols. Alcohols are really similar to alkanes, except that one of the hydrogens is replaced by an OH group, which is the alcohol group. Okay. So for example, I'll start with the simplest possible alkane. Right? Talked about alkanes forming carbon chains. The simplest alkane is this one, where it's so short it doesn't really look like a chain. It's just a single carbon, but it still follows all the same rules. So this is the shortest possible alkane that you could have, and we can make the corresponding alcohol just by replacing one of those hydrogens with an OH group, right? And so now this structure on the left is an alkane, and this one on the right is an alcohol. When I do these alcohols, and when you do them for us right now, I would say let's always just go ahead and put the OH on the far right, just because it's easiest to put it there. But this would be the same structure if you put the OH over here, and that's perfectly acceptable. You can really put it anywhere. Let me show you on another slightly longer alkane. So if we take, for example, a 3-carbon alkane, here's our alkane. And the corresponding alcohol we can get just by swapping out one of those hydrogens for an OH group. Oops. All right, so here's our corresponding alcohol. Now, when you get to organic, when you get to more advanced courses, you'll see that this molecule here with the OH on one end is a slightly different molecule than this one with the OH in the middle. Okay, but for our purposes, we're not going to worry about that. And so that's why I would say, what I said before, let's just go ahead and put the hydrogen, or excuse me, put the OH group on the end of the chain for all of those. That's the simplest version of the alcohol. If you put it somewhere else, I won't mark it as wrong. Oops. Boy, what's wrong with me today? Okay. I won't mark it as wrong no matter where you put it, but the best thing to do is just to stick it here on the end, because that represents the simplest form of the alcohol. And like I said, you'll see the difference between those when you get to organic chemistry. Your teacher will talk about the difference between those different alcohols. All right, now let's look at how we name these guys. And in order to do that, we need to have this little table. And here's a table of prefixes for organic compounds. Some of these prefixes are going to be new to you. For an organic molecule with 1 carbon, here the prefix is meth. For 2 carbons, it's eth. For 3, it's prop, and for 4, it's bute. I had a student once who kept calling this butt, and so she would be drawing pictures of butane and butanol, and I didn't want to correct her. I just kind of laughed a little bit to myself, but it's bute. Okay, so the prefixes for 1, 2, 3, and 4 carbons is meth, eth, prop, and bute. And then after that, they follow a pattern that you're probably pretty familiar with. These simple, I don't know whether they're Greek or Latin, but these simple prefixes that you remember from geometry: pent, hex, hept, oct, non, and dec. Just like a 5-sided figure is a pentagon and a 6-sided figure is a hexagon, and so on and so forth. So those are the exact same roots that you're already familiar with. I think the only new ones are likely to be these first 4: meth, eth, prop, and bute. Okay. All right, so write these down. Make sure you've got these. These are important. Definitely something you'll need to memorize. Again, since this is just simple basic knowledge, right? This would be an example of a low-level learning goal in the Bloom's taxonomy. And so this would be the kind of thing that is perfect for flashcards, right? Or whatever other method you want to use to memorize them. But make sure that you know this table. Okay, so now if we want to use those prefixes for naming alkanes and alcohols, The rule for alkanes is that the compound is just named blank ane, where we insert the appropriate root based on the number of carbons. So for example, one of the ones that we've been using, this 2-carbon chain, we used this as an example a couple times. Because there are 2 carbons in there, the appropriate prefix is F, and so this molecule would be ethane. Right? And the formula for ethane would be C2H6. Okay. As long as we're talking about these formulas, I want to mention something else about these. Once you get to organic chemistry, I guess let me back up a little bit. We talked about ionic compounds. If we had something like sodium chloride, we would always just write it sodium chloride. And there's not really much else you can do with that. That's really the only way to write it. For organic molecules, because they can form chains and things like that, sometimes we find more creative or more descriptive ways of writing this. So if you're writing the formula for ethane, you can write it as C2H6, and that's obviously perfectly fine. That's a wonderful way to write the formula for ethane. But in order to indicate that you've got this carbon here connected to this carbon here, to kind of give you an idea of the structure, people might sometimes write this as CH3, CH3, and that gives you the added information that you've got a CH3 group here connected to another CH3 group here, right? So you might see the formula for ethane written in either of those 2 formats. Let me give you another example so you can see a little bit more clearly how this gets used. Let's take a longer alkane. Let's try, I don't think we've done one with 6. Let's do one with 6 in it. Okay, so here's a 6-carbon chain, and following our rules for alkanes, we know that each one of these carbons has to have 4 bonds. Oops, let me put the bonds in first. Okay, and then we go back, and at the end of each one of these bonds, we put a hydrogen atom. All right, so this is the structure of a 6-carbon alkane. And if we go back and look at that table, we remember that the prefix for a 6-carbon organic molecule is hex. And so this molecule is hexane. And if we want to write the formula for this, we've got a couple options. One, we could just count up all of the carbons and the hydrogens. There are going to be 6 carbons and 14 hydrogens. Right? We can get that by just physically going through and counting all of them. You could also use that equation we had before. Right, where the formula is going to be CnH2n plus 2, and the 2n, of course, comes from the hydrogens above and below the carbons, and this plus 2 is the hydrogen at each end of the chain, right? So this this formula here, this is a lovely and wonderful and reasonable way to write the formula for hexane. But in order to indicate that this is a long chain of carbons, you could also write it this way. So you'd sometimes see this. We've got a CH3 here at one end. We've got a carbon connected to 3 hydrogens, right? And then next, we have a carbon here that's connected to 2 hydrogens. And then we have another carbon connected to 2 hydrogens. And another carbon connected to 2 hydrogens. Another carbon connected to 2 hydrogens. And then finally at the end, a carbon connected to 3 hydrogens. Okay. So this is another way to write the formula for hexane, right? And this helps to make a little bit more clear that all of those carbons are connected in a long chain, right? This is sometimes referred to as a structural formula. And then the second one here, the structural formula, gives you a little bit more information, so it's a little bit more useful. Like I said, it's kind of a nice way to write this, but it's also a little bit cumbersome. So we can write the same thing a little bit more simply by noticing that there's a CH3 at this end, a CH3 at this end, and 4 CH2s in the middle. So we could write this structure this way as well. CH3, CH2, CH3. So this is another way of writing the formula for hexane. All three of these are perfectly reasonable and perfectly acceptable. I don't think there are any circumstances where I would require you to write one or the other, but you might see all three of these. And so I wanted you to be familiar with all of these and see that all three of these things are really saying the same thing. Okay? So that you don't get thrown off if you see it in a slightly different form. All right. And then alcohols are named very similarly to alkanes, except for the suffix at the end. Instead of ane, the suffix is and all. Right? So if we take a real simple one, let's take the 1 carbon chain. Right? Our alkane would have hydrogens all around the carbon, and the corresponding alcohol would have an OH substituting for one of the carbons. If we look at our table, the prefix that means 1 carbon is meth, and so this would be methanol. Right? And let's try another one. Okay, so here's another one. This is a 4 carbon chain that has an alcohol group at the end. So we just look at our prefixes. The prefix for 4 carbon chain is bute. And so this would be butanol. All right. And I guess I'll make a similar comment about the formulas here. For butanol, we've got 4 carbons, 10 hydrogens, and 1 oxygen. So one way that you could write this would be C4H10O, but that kind of disguises the fact that there's this OH group on the end. So it would probably be considered better to write the formula like this so that you can see that OH group. And so we might write this as C4H9OH, right? That'd be a slightly better way to write this. And we could do what we did before with the structural formula, we could look at this first carbon as a CH3 group. We could write this as CH3, CH2, 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 OH. That would be another way to write this. Okay. And again, I'm not going to be picky about these. You can write these in whichever one of these makes the most sense to you. I'm just pointing it out because you're liable to see it in a couple of different ways, and I didn't want it to throw you. Right? And I will say in this case, these last two are a little bit better than that one. This one here is not wrong. That is correct formula, but because this is an alcohol, it's really nice to be able to write this in a way that highlights that OH group as a single unit, rather than sort of concealing the OH as it is in that formula there. Okay. But again, if I ask you for the formula for one of these, as long as you have the right number of carbons, right number of hydrogens, right number of oxygens, that'll be fine. Okay, let's try a little practice. We've got a mixture of alkanes and alcohols here. Hit the pause button and then work through these and see if you can write names for these alkanes and alcohols. Of course, first thing you have to do is figure out whether it's an alkane or an alcohol, and then figure out what the correct name is. Okay? All right, go ahead and take a crack at that, and then we will work on them together. Okay, the first one is just carbons and hydrogens. There are no OH groups on here, so this is an alkane. And so to name it, we just have to count the number of carbons here. There are 4 carbons. The prefix would be bute, and because this is alkane, this would be butane. Okay. For the next one, we recognize this OH group here, so this is an alcohol. So the name is going to be something anol. We just have to figure out how many carbons we've got. There are 2 carbons, and the prefix for 2 carbons is eth. And so this would be ethanol. Okay. For the next one, there are no oxygens in here, so this one's got to be an alkane, right? You can see by comparing this first one, this structural formula is a lot better at showing you what the molecule looks like than this more condensed form is here. All right, but since we're just looking at alkanes and alcohols, we can look at this one and see clearly that this one is an alkane because there are no oxygens, and there are 7 carbons in it. The prefix that goes with 7 is hept. So this would be heptane. Okay. And for our next one, we've got this OH group here. So this one's clearly an alcohol. And we've got 3 carbons. The prefix that goes with 3 is prop. So this would be propanol. Okay. And then this last one, now we've got a little bit interesting. We've got this structural formula with this group in the middle, right, with 4 CH2 groups, right? So this would be a CH3 group, 4 CH2 groups, and then another CH3 group. Right. So clearly it's an alkane, and if we count up the total number of carbons, we've got 6 of them, right? A CH3 on each end and 4 CH2s in the middle. So the prefix that goes with 6 is hex, and so this one would be hexane. All right. Okay, let's try a couple going the other direction. So here I've given you names, and I would like you to give formulas So, and actually give a formula and also sketch out the structure. Do a little molecular sketch for each of these. All right, hit the pause button, work on these, um, and then unpause, and we'll see what we've got and compare our results. All right, the first one is propane. Right, so the ane tells us that this is an alkane. There are no oxygens in it. The prop tells us that it is a 3-carbon chain. So we'll just put our 3 carbons there, and then we'll surround everything with hydrogens. So that's our structure, and our formula can be C3H8, right? If you wanted, you could write this as C3CH2CH3. Either of those, of course, are fine. Okay. For our next one, hexanol. This tells us we've got a 6-carbon chain, and the all tells us that it's alcohol. So you start with our 6 carbons like that, put hydrogens all around. And then where the last hydrogen would have been, we'll substitute an OH group. And for our formula, we can write this a couple of different ways. We've got 6 carbons, 6, and I'm going to go ahead, I'm going to leave that OH group by itself. And so instead of putting the oxygen at the end, I'm just going to count the hydrogens here in this little box. Right? And so this is 13 hydrogens, right? C6, H13, OH, right? Or you could have written this as CH3, CH2, 5, OH, right? Or you could have written CH3, CH2, 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 CH2 5 times, and then an OH, right? However you want to do it. And again, either of these are good ways to do this. And in fact, if you had written C6, H14O, that's not the best way to do it, but it's not technically incorrect, so that would be okay too. All right, next one, methanol. The anol tells us an alcohol, and the meth tells us that it's a single carbon. Right, so this one's really simple. Let's go ahead and put our OH on there. Boy, for a simple one, I sure am having trouble drawing it decent. All right. All right, so there we go. There's our structure. And then for our formula, just write CH3OH, and that's methanol. All right, last one's octane. I'm going to take a minute to clear some of the writing here so we've got some room, and then I'll be back in just a second. Okay, the oct prefix tells us we've got an 8-carbon chain, so I've gone ahead and drawn 8 carbons here. The ane suffix tells us that it's an alkane, so around all of these carbons we just have hydrogens. Okay. So our structure looks like that. That's what the octane molecule looks like. And then for the formula, we can just count up all the atoms. We've got 8 carbons and 18 hydrogens. Again, that's what you would get if you use the CnH2n plus 2 formula equation. That's also what you get if you just count everything. So we can write the formula that way. We could also have written it as CH3 and then 6 CH2 groups and then another CH3. Right? Those are 2 perfectly reasonable ways to write the formula for octane. All right, terrific. So in this video, we talked about organic compounds, talked about what they are, which ultimately boils down to the fact that they are molecules that are based on a carbon skeleton, basically, right? A bunch of carbons linked together. We talked about 2 specific classes, 2 very simple ones, alkanes and alcohols. There are, a couple of dozen different kinds of organic molecules that you'll get to learn about in organic chemistry. But for right now, we're just looking at these 2. We've got that table of numerical prefixes. The first 4 are meth, eth, prop, and bute. And then after that, they follow the prefixes that you're familiar with from geometry and other things like that. So you need to know those prefixes. And then we use those prefixes for naming alkanes, which I have the name prefix ane, and for alcohols, which have the prefix and then the suffix -all at the end. All right. You should also, this is about applying names based on the formulas, but you should also be able to go, from formulas to names, but also from names to formulas, right? You should be able to go back and forth easily. All right, terrific. That was your introduction to organic chemistry. And I think that actually ends our chapter on chemical nomenclature. Terrific. Please work through those in the study guide and let me know if you have any questions.